Hello students, welcome to section 7-1, Ratios and Proportions. Today we're going to take a look at writing and using ratios. A ratio, as you recall hopefully from Algebra 1, is a comparison of two quantities by divisions. The ratio A to B, where B is not 0, can be written as A over B or as this A colon B representation. Example 1. In 2007, the Boston Red Sox baseball team won 96 out of 162 games played. Write a ratio for the number of games won to the total number of games played. So to find the ratio, you're going to divide the number of games won by the total number of games played. So the simple ratio, as you can see, or fraction, same thing, is 96 divided by 162, which is about 0.59, or as a percentage, 59% of their games. Example 2. The ratio of the measures of the angles of angles in triangle JHK are 2 to 3 to 4. The angles are also represented with variables, with J being 2x, which is technically what it should be because J comes first in the setup. H should be then, well, they have it as 4x. I think it would be more accurate to be written as 3x. It could be by virtue of just maybe how they drew it. We'll see how the answers unfold anyways, but K technically should be written as 4x, but they have it as 3x. In the end, you're actually going to find x to be the correct number that they provide anyways, but we'll go ahead and plug it in and maybe decipher as such how it relates to the picture. Anyways, 2x to 3x to 4x is how we're going to rewrite that ratio of 2 to 3 to 4. And as it turns out, again, noting the picture and noting that three angles of all triangles are always going to add to 180 degrees, simply then 2x plus 3x plus 4x, of course, equals 180. So the ratio of the angles, again, because they're 2 to 3 to 4, we can add them up as such with x. Of course, this adds to 9x, and then if you divide both sides by 9, you end up with the exact answer for x, simply to be 20. Not quite done, though, with the problem. Once you get x to be 20, because you still have to find the measures of the angles, they say, we're going to plug it in accordingly. So 2 times 20, that's easy enough. That's 40. Of course, then 3 times 20, that's 60, and then lastly 4 times 20, so 80. So 40, 60, and 80. And yes, those three angles do add up to 180. As it turns out, in terms of labeling the angles according to 2 to 3 to 4 or 4 to 3 according to the letters, that's actually not necessarily as important as deciphering what x is and then of course finding each respective angle. It may not be the case then that each angle we can assess or attribute, to J, H, and K specifically or respectively for that matter. These answers are good enough. All right, moving on. In the 2007 Major League Baseball season, Alex Rodriguez hit 54 home runs and was at bat 583 times. What is the ratio of home runs to the number of times he was at bat? So as you can see, I've already set this up. We've got our numerator of 54 divided by our denominator of 583. So our ratio, if you guys simplify, ends up being this particular decimal. So it's approximately 0.0926. There are 182 girls in the sophomore class of 305 students. What is the ratio of girls to total students? Simply 182 divided by 305. And if you do the math on your calculator, that's about 0.5967. The length of a rectangle is 8 inches and its width is 5. What is the ratio of the length to the width? So 8 inches in the numerator divided by 5 inches in the denominator, so 8 to 5 or 1.6. Number 4, the ratio of the sides of a triangle is 8 to 15 to 17. Remember, this is sides, not angles, as we saw up in the example above. And because they gave us the perimeter as 480 inches, we can find the length of each side. Without necessarily drawing a picture, think of, again, 8x as one side, 15x as the other, while 17x is the third. If you add these three lengths, again, as an expression, you're still adding them to set equal to 480. Because you know the ratio of sides, you can add them up with x. course, then you get 40x equals 480. Dividing by 40 then should yield x in this case to be 12. Now you're not done, because we want the length of each respective side, right? So 12, if you plug it into this expression, 8 times 12, you get 96. Into this expression, you get 180. And then lastly, 17x, or 17 times 12, of course, is 204. Double check, but these three dimensions, in fact, add up to 480. And you can even go one step further and see that reducing these by a factor of, 15 and 17, 96 divided by 8 should be 12. 180 divided by 15 should be 12. And then 204 divided by 17 should also be 12. So we call these values in a proportion, of course. We can talk about proportions later, but in a proportion would all be equivalent. All right, the ratio of the measures of three angles of a triangle is 7 to 9 to 20. Find the measure of each angle. So similarly as what we saw, not just on number 4, but more specifically on the example up above, remembering that the three angles of a triangle will add up to 180. And notice I've already set us up such that 7x plus 9x plus 20x is equal to 180. Without even really needing a picture here, we know the three angles of a triangle, as again each individual expression gives us the angle, add up to then 180. These add up to 36x. Divide by 36, so you end up with x to be 5. Now we're not done. Once you get x to be 5, you still then need to plug it in here. So 7 times x, of course, 35, so 35 degrees. 9 times x, or 9 times 5, 45 degrees. And then lastly, 20 times 5, of course, they're 100. These three angles are the three angles of your triangle, and of course, they add up to 180. All right, moving on. So using properties of proportions, a statement that two ratios are equal is called a proportion. So I've already alluded to this idea on the prior page a little bit. In the proportion, A over B equals C over D, where B and D are not 0, the values A and D are called the extremes, so these two quantities. And the values B and C are the means. So we have extremes and we have means, and they actually express that quite nicely here as well as a product, right? A times D will cross multiply as the extremes, and B times C, again, there being the means. So means versus extremes. In a proportion, the product of the means is equal to the product of the extremes. So yes, AD should equal BC. And yes, I've also referred to this as the cross product property. And likely this is also something you've seen in Algebra 1. Example 1. So we're going to solve this proportion. 9/16 equals 27 over x. We're going to cross multiply 9 times x, there it is, as your extremes. And then 16 times 27, there it is, as your means. Okay, divide both sides, and the next step, as you can see, 9x equals 432. Divide by 9. So in the end there, you see that x is simply 48. All right, let's move on to the next example, and we'll talk about more below. Politics. Mayor Hernandez conducted a random survey of 200 voters and found that 135 approved the job she is doing. If there are 48,000 voters in Mayor Hernandez's town, predict the total number of voters who approve the job she is doing. So we're going to write and solve a proportion that compares the number of registered voters and the number of registered voters who approve of the job that she is doing. So as you can see, on the left side of our proportion, we've got 135 over 200. Which is the random survey relationship that's being made. 135 approved divided by the 200 that were surveyed. If we set up on the other side of the proportion the voters who approve, which we don't know overall, measure that against 48,000 total voters, we'll have a better idea, roughly speaking, as to a prediction, let's say, of how many people would approve out of the total. So 135 over 200 again equals x over 48,000. So we'll do our cross product as they describe, cross products property. 135 times 48,000, that's 6,480,000. On the other side, 200x, there it is in the next step. So dividing both sides by 200 there, you see, as it turns out, x is equal to 32,400. So based on the survey, about that number of people who are registered voters will approve of the job that she is doing. If we were to actually compile the data on this, who knows how close to 32,400 you would actually get, because maybe this random survey, who knows, maybe this random survey isn't particularly as maybe accurate as it could be. Maybe it's only representing the people that in fact voted for her, for example, or people that like what she's doing, type of thing. So the approval rating numbers as a projection here is just that. It's it's projecting what would likely happen if you took a survey of the whole population. All right, let's finish up. Number 1, this is a simple proportion. If we cross multiply here, we got 1 times x. There it is. 2 times 28. There it is on the other side of the equation. This, of course, ends up being 56. So in the end, you end up with 56 for x. Number 3 is a little bit more nuanced because we have a binomial divided by another binomial equals a simple fraction. So I went ahead and I put parentheses around x plus 22 and x plus 2. So when you cross multiply, you're going to have 10 times this quantity in parentheses. Be careful, make sure you do that. And on the other side, the same thing applies, 30 times the quantity x plus 2. Make sure the parentheses are there. Make sure then that if you don't necessarily distribute, that you are able to do something like this. And I say make sure, if it's plausible, only do that. So I did end up dividing both sides by 10 just to make my life simpler, such that on the left side it's nicely x plus 22, and on the right side 30/10 is nicely reducible. So I end up with 3. Now I'm still going to have to distribute the 3, but doing this prevented me to have to maybe distribute, or from having to distribute the 10 to the left side and the 30 to the right side, which still technically could be done. I did it this way for simplification purposes. Now if you distribute the 3 on the right side, you've got 3x plus 6. This is still x plus 22. Subtract x, you get 2x. Subtract 6, you get 16. Divide by 2 in the last step there, you get 8 for x. Number 7, if 3 DVDs cost $44.85, find the cost of 1 DVD. All right, so I wrote my first ratio as 3 over 44.85, or you could flip it as 44.85 over 3. And then my right side of my proportion, I wrote my ratio as 1 over x. But again, I could have written it as x over 1. Just be careful. If you flip the left side as such, you're going to have to also flip the right side in the same manner. Anyways, in this particular instance, though, if I cross multiply, I've got 44.85 times 1, so there you have it. I've got 3 times x, so of course there are 3x. There you have that. Divide both sides by 3, and it turns out that 1 DVD, x, I'm noting here as $14.95. All right, last but not least, number 8. Byron is measuring plants in a field for a science project. Of the first 25 plants he measures, 15 of them are smaller than a foot in height. If there are 4,000 plants in the field, predict the total number of plants smaller than a foot in height. So the first quantity, 25 plants, that's the total. Divide that by 15 in this case, which are smaller than the height that he's denoting here as 1 foot. On the other side of the proportion, we know that there are 4,000 plants in the field, so that's also in the numerator. So plants are in the numerator on both sides of my proportion. That's important. Same units on both sides in the numerator, as well as then in the denominator, which I don't know, predicting the total number of plants. So if 15 in the denominator was the quantity that's smaller than a foot, x, which is the unknown, of course, here, we don't know that because, well, that's what they're asking with regards to then relating to the 4,000 plants total. As a ratio, 25/15 equals this ratio, 4,000 over x. 25 is to 15, we say, as 4,000 is to x. We cross multiply. 4,000 times 15 is 60,000. This cross multiplies to 25x. We divide both sides by 25, and we end up with 2,400 plants. One thing that I do encourage you to try doing on pretty much any proportion that you work out is taking your final answer and plugging it into the original to see that your proportion is equivalent. So if you were to plug in 2,400 here, 2400 in this denominator does in fact simplify what? 4000 divided by 2400 as 25/15, which is also reducible to 5/3 if you wanted to continue with the simplification.